The potato was brought from its native home in Peru to Spain, and in time back to America, and now spreads its green over countless acres throughout the world. A universal food for the millions and the millionaires. Not all the gold that Pizarro plundered from the Incas can compare with the wealth that a peaceful monk took from Peru, impoverishing no one but enriching all mankind. Whether in the shadows of the Grand Tetons or in the arid Southwest, the potato is at home. It thrives in any temperate zone and in varieties which have been produced by the conjoint influences of man, environment, and climate, differentiated during nearly 400 years by patient scientific endeavor. And not by any easy way has the potato been preserved from the bugs, blights, and banes which have assailed it down the centuries, enemies that threaten every phase of its life from seed to service. Whether the potatoes are to be grown for certified seed, to be sold to commercial growers, or for the market, most of the procedures are identical for identical local conditions. This field will perhaps be worked several times before planting. Note that two operations proceed at once. A harrow follows the plow, conditioning the soil to a finely prepared seedbed, as in this before and after scene. This great field will produce thousands of bags of commercial potatoes, the ultimate of large-scale operations. In this operation, the soil is well pulverized. With different types of soil in other localities, a firmer seedbed may be desired. Therefore, the soil may not be worked so intensively. Free irrigation is common practice where the soil is deficient in moisture at the time of seedbed preparation. It aids in the proper preparation of the soil. It speeds the breakdown of organic matter. It aids bacterial growth and stores moisture for the plant to use. After plowing comes disking and harrowing, breaking up the veins of channeled moisture into friable uniformity ready for seeding. In some areas, alfalfa, previously enriched by phosphates, is plowed under to add rich, water-holding humus. Good manure, high in nitrogen content, reinforces the nitrogen placed in the soil by the disintegrating alfalfa. Roots, leaves, stems, the entire plant of nitrogen-rich alfalfa is plowed under to aid bacterial action, improve soil structure, increase water-holding capacity, promote aeration, and provide a constant supply of food for the growing plant. No farm practice does more for the soil. Thorough disking of the field firms the seedbed by filling up the air pockets. These weak plants grew from virus-infected seed. These healthy plants from good seed. The battle to produce good seed is part of the battle against disease. And here will be determined the character of future potato crops. For this is the unfolding of a program to produce indexed foundation seed for certified seed growers who produce seed for table stock, seed with a pedigree. The seed piece from each potato is identified by the number on the belt, and the knife is sterilized to prevent spread of disease. The potato will be stored after being given the number of the seed piece. These in lots of 100 each will then be ready for planting. Note that the potato and the removed seed piece remain together on the numbered space until each has taken its number from that checkered square. This is important, for the integrity of the certified seed depends on the accuracy of the identifying numbers. To the figures on the moving belt are added the hundreds as the operation continues until 1,000 potatoes have been cut. The numbered parent tubers are stored 100 in a box, and the burlap is sprayed with water to hasten suberization or healing. The one on the left has been suberized, the other freshly cut. Meanwhile, the index seed pieces are being placed numerically in the 100 squares of a planting board. When the board is filled with each seed piece on the squares correspondingly numbered from 1 to 100, accuracy is ensured. The seed pieces, thus double-checked, are ready for planting. This is done in plots of 100 each, the rows corresponding to the rows of the planting board. 10 rows in the plot are identical with the 10 rows of the board, and the glance will reveal the identity of each plant as it thrusts its hurried way through the friendly soil. In this row begins the next 100th index seed piece. Each 100th plant will be disclosed by the stake at the end. Another version of the established greenhouse of glass. This economical cloth-covered shelter is easily re-established in new areas from year to year where the soil is relatively disease-free. Under such stimulating conditions, plant growth is rapid. Soon it is time to check each plant, the number of which corresponds to that on the parent tuber kept in storage. Here he finds a diseased plant, Mosaic. 106 is as revealing as a rogues gallery number, and the parent in the cellar is already doomed by the number of the diseased plant, which is registered on the chart. The FBI shows no greater relentlessness running down criminals. The virus diseases against which indexing is a safeguard reduce the yield, but do not render potatoes unfit for eating. Back in the cellar, each guilty parent is put in condemned row and will be destroyed. And there they are. Potatoes 108 and 106 are mosaic-infected tubers. With the diseased parents eliminated, the rest have been certified disease-free by nature and are ready to be planted by foundation seed growers, their progeny destined to be certified seed. With all the diseased parent tubers removed, only healthy ones remain. The seed pieces cut from each parent tuber are carefully placed together in a hallock, one tuber to each hallock. This tractor-drawn assisted feed planter is used in the operation of tuber unit planting. The seed pieces are dropped into adjoining compartments with an empty one in between to mark each parent unit. As the machine proceeds, the seed pieces are dropped into place, and each empty pocket will space the units clearly. Thus, should any seed piece yield a diseased plant, all the other plants from that particular parent will be destroyed. Index planting in a greenhouse is identical with the index system we have seen. Research workers of state colleges and federal agencies, Union Pacific agricultural agents, and growers associations all participate in this improvement of foundation seed stock. This special adaptation is also for tuber unit planting. The seed potatoes of uniform size are cut into 4 pieces on the planter. Forcing the potatoes against the blades, the seed pieces slide into the 4 cups and into the ground. Spacing is also automatic, and errors in planting are impossible. A jet of disinfectant from this tank on the front of the planter sterilizes the blades after every cut. Planting in groups of 4, as indicated by the space between units, enables the grower to remove suspected plants whose common parent has yielded the diseased one. Roguing the field to eliminate diseased plants is necessary in order to produce a field which will be certified by state inspection. In the later roguing, the tiny diseased tubers must be removed. Here the inspector, with the grower, is giving the field a preliminary going over. Even though he may be obliged to withhold certification of the crop, he remains the grower's friend. Both understand that the very existence of the potato is threatened in this ceaseless struggle of science versus disease. Several official inspections may be necessary before the field is certified. The closest scrutiny of plants and careful notes provide the inspector with a case history. The percentages of the diseases found are recorded. In these test plots, the suitability of various seed lots for commercial plantings is being determined. On the right, a diseased row shows a high infestation of mosaic. On the left is a healthy row. These scrawny ones are afflicted with mosaic, a virus disease. These are perfectly healthy. Reduction of yield is shown by the smaller tubers on the right from a mosaic-infected plant. In his greenhouse, the grower can determine the types and percentage of diseases with which his seed may be infected. Compare the mosaic leaves with the healthy plant on the right. The entire mosaic plant is unhealthy and will be eliminated. A well-defined case of witch's broom, contrasted with a healthy, thriving plant. Leaf roll is shown on the right, as may be seen by the rolled leaves, which are typical of this virus disease. Blackleg has gripped this plant. It is a bacterial disease blackening the stem near the soil line. This manifestation is clearly seen in the advanced stages. These rotted portions of the stem testify to its deadly virulence. Spindle tuber, the disease affecting this spindly plant, tends to reduce the grower's yield. Their shape inspired the name, spindle. This contrast between a normal potato and a spindle tuber clearly shows the grower's loss. A sinister plague called rhizoctonia goes on beneath the surface of the ground, destroying the plant through progressive rotting of its stems before they emerge from the soil. This plant has been hit by ring rot. Verticillium wilt, or early dying, like ring rot, may strike entire fields. And here is ring rot again, manifesting itself in its early stages in this scented plant, which quickly will lie prostrate and dead as the disease continues its fatal advances. Laboratory tests may be necessary to determine the presence of ring rot, which, because it is so insidious, is one of the potato grower's most serious menaces. The juice from the plant stem smeared onto the slide and stained reveals no ring rot. The red in this case indicates not danger, but safety. This slide definitely indicates the presence of ring rot. The tiny black dots are ring rot organisms. Literally, it is the black plague, ring rot, which is betrayed to the eye of science long before the plant itself reveals the slightest evidence of its own approaching doom. As the disease advances, and while it still shows no visible signs to the naked eye, it is nevertheless at its deadly work, hence its name, this fatal rotting ring of death. As the disease continues its ravages, its presence produces unmistakable external manifestations of an inner corruption, until at last it is done for, a loathsome finish, a threatened famine maker. Small growers find this rotary disc seed cutter good equipment. The blade is sterilized in boiling water beneath the table. Stationary knives are satisfactory if seed potatoes are relatively disease-free. Here, potatoes are brought from the storage room to be run through sprays of cleansing water. On their continued way to the cutting table, they will be subjected to a disinfecting bath. This is it, and a thorough job is done on any lurking organism. 5 women here are cutting seed. Note the rhythmic performance of this fast operator. Cutting potatoes by note, so to speak, really makes for efficient operation. The sacks of seed we have seen cut have been kept under canvas to protect them from excessive drying. Continuing operations in the field where alfalfa and barnyard manure were turned under is a 2-row picker-type planter. Though the alfalfa has been turned under less than 24 hours, it'll be broken down for plant food by the time the plants need it. Where a particularly heavy stand of alfalfa is plowed under, it is the practice in some areas to let the ground stand several days before planting. Generally speaking, the time lapse between cutting the seed and planting should be brief. This 4-row high-speed picker planter, in extensive areas of radically different soil, deposits the seed pieces and fertilizer at the same time. Once the numerous and extra capacious bins are filled from a field delivery truck. Commercial fertilizers are used more extensively in some areas, depending on soil conditions. This equipment answers all requirements of speed. It plants the seed pieces, it drops the fertilizer, and it covers both with soil, which in this case, unfortified by fertilizer, would not produce a satisfactory crop. Fertilizer and seed are being covered, the soil serving to contain the fertilizer against the time when the growing plant needs its nourishment. The rotating pickers on the wheel give the equipment its name, as they speedily pick up and deposit the seed pieces in the soil in close proximity to the water-soluble fertilizer. This is indispensable for good plant growth and a satisfactory maturing of this particular crop. Here the hill has been cut away to show the two bands of fertilizer and the seed pieces which they'll nourish with the laying on of water. Emergence of plants, though deeply sown, will be quickened by the conditioning of the soil and the certainty of adequate water through controlled irrigation. God helps those who help themselves, and the cup of his abundance runneth over. Irrigation, which paces the growth of the entire plant, can be regulated more effectively by man than by nature. Here, every other row, every other day can be served by waters controlled at the head gate. The amount of water needed is determined by the soil texture and rate of evaporation. Note the secondary ditch on the right with its evenly spaced pipes, which enable the grower to remain master of the flow of water to his plants through a constant level of supply. The pipes prevent breaking down of the ditch sides, while the secondary ditches are terraced to correct the necessary angle of flow in the long main ditch. Every row irrigation is common in many sections where water is applied less frequently. This is the field, however, in which alfalfa was plowed under, rendering the soil abundantly absorbent, as can be seen. With initial irrigations in soil so conditioned by humus, irrigation of every other row provides sufficient moisture due to the high absorption quality and increased water holding capacity. Digging away the topsoil clearly shows the extent of moisture penetration. With the same type of soil but lacking in humus, every row application of water is necessary from the start. Cultivating controls weeds and provides furrows for irrigation. It also builds the ridges over the potatoes, preventing sunburn. In dry farming, cultivation destroys weeds, thereby conserving moisture. This cultivator, equipped with duck feet, cuts the weeds, breaks the crust, and stirs up the soil, ensuring better absorption of water when it rains. Over and under spraying under high pressure will not miss a bud. A watcher is on the job to see that every spray is on the job. Insect poison may be served to the customers by dusting instead of spraying. Here the farmer has contrived an ingenious canvas covering which protects the operation even in a wind. This may be one of several such poison dustings if infestations are bad enough to require them. Additional nozzles to give more complete coverage are often used for other types of insects. Harvesting time means long hours in the field. These men start work as soon as the sun has warmed the air. There's a minimum of bruising as the digger reaches underneath the potatoes, drawing them forth cushioned by their own vines and soil. An injured potato is a ruined potato commercially. Getting it out of the soil unharmed is only the first problem. Note that the potatoes make but a short drop from the endless chain. On the ground, they are retrieved by pickers who know that a bruised potato in the field means a damaged one in the storage warehouse. The wire baskets are covered with rubber. To prevent damage to easily bruised potatoes, haste must not make waste. In transferring potatoes from baskets to sacks, care is taken that they don't have far to fall. When potatoes are ready to harvest, a rotobeater may be used to break off the vines at ground level and pulverize them. The machine has corded rubber fingers that revolve rapidly, flailing and destroying all top growth. It hastens potato maturity and leaves the ground free of troublesome vines, simplifying the digging operation. Undercutting also kills the vines and thereby hastens maturity of the potatoes by reducing the moisture supply. But not always can care and solicitude for a spud's welfare result in a crop like this. It's a fine crop of netted gems, copious and wonderful in size and conformation. A fast, widely used picking method utilizes sacks suspended on a two-hook belt. In some sections, a canvas sack is used to prevent windburn. From field to storage cellar, a truck will take the sacked potatoes for a ride made comfortable by the padded truck bottom. Padding on the truck is one of the best ways to reduce damage to the potatoes. It also speeds loading operations. This method of stacking the potatoes is the result of long experience, too. The objective is to distribute pressures evenly throughout the load, for it is obvious that there'll be rough going from field to storage. Here's a high-speed two-row digger getting early potatoes out of the ground in a hurry. In this extensive operation, the potatoes are destined for early market, and speed is the essence of success. It is necessary that the tender potatoes be quickly picked up to avoid the ravages of wind and sun. The field has been hard hit by a timely frost and all the vines are dead. The peg-tooth harrow with teeth slanted well back breaks them up, leaving a dust cloud in its hurried wake. This is a single-row potato digger and sacker. The machine's digging blades reach well below the tubers and lift them onto a conveyor, the crossbars of which permit the loose dirt to sift through. The crossbars are rubber covered to prevent bruising of the potatoes. They continue on to a table where vines and remaining clods are removed. By this rapid process, which sacks the potatoes on the combine, time and labor are saved in harvesting this field, which yielded 350 100-pound sacks to the acre. The grade, incidentally, was better than 90% U.S. number 1. A profitable crop and ready now for removal to the storage cellar. This machine effects a fast and efficient operation. Composed of a two-row digger and elevator, it is ideal for handling potatoes in bulk. As a chain conveyor carries the potatoes up the elevator, it shakes out the dirt. The potatoes continue on across a table where men remove the residue of small clods and vines. On reaching the top of the elevator, the potatoes drop into a truck moving alongside. This machine should prove economical where large acreage warrants its use. The bottom of this newly designed potato truck is actually an endless belt conveyor. Upon delivering spuds for storage, the motor-controlled conveyor in the bottom of the truck is started and moves the spuds out into a hopper, from which they are conveyed up to huge holding bins. The bottom of the bins are also equipped with conveyor belts, which move the potatoes to various parts of the building. Bulk storage enables the grower to handle potatoes in large volume, quickly and efficiently, with a minimum of labor. The cleaning process starts with dropping the potatoes down a chute, the bottom of which is screened, permitting loose dirt to sift through. They then continue on to be graded. Market requirements necessitate the use of storage cellars, many of which are underground or half-subterranean. This is a sort of half-and-half type with soil heaped on the curving roof. In some places, the underground storage has given way to this cement type of above-ground storage, many of which are found along the Union Pacific tracks enjoying its fast service. Such storage facilities reduce the hazards of long truck hauls at market time in winter and greatly reduce time in getting potatoes from the storage cellar to your table and mine. The first leg of that important journey is now ended, while the second leg of steel is all steamed up and ready to go. Built for bulk storage, this type permits trucks to back into the bins and exit quickly when unloaded. The sacked potatoes are emptied onto a conveyor or piler. Bins, when filled, are boarded up until the potatoes are to be removed. Some varieties, such as Bliss Triumph, require more care in handling. If the potatoes are handled in sacks, hand trucks convey them to the washer and grader when the grower orders them out for these necessary pre-market operations. This trough, built in the floor of the storage plant, floats the potatoes from storage rooms to be graded. They are washed as they float along until they come to a concrete basin at the foot of a conveyor. Little time is lost as they are lifted and carried to the grading table. Running the gauntlet of watchful eyes, quick to detect for removal undersized below-grade potatoes. The rubber pads are designed to offset the length of the fall. The graded potatoes, now sacked, are removed to the weighing platforms where a special padded frame reduces the shock of jigging. This barrel washer is but one of several used in different types of grading equipment. It feeds directly to an elevator, thence to the grading table. Careful designing of washing and grading layouts is disclosed in this view of one type of grader. Many objectives are kept in mind to facilitate and therefore speed the operations. Here, the potatoes are being waxed in order to preserve their moisture content. The element of time becomes most important when speed is required to reach an advantageous market suddenly developed. Paper bags are used in many sacking operations. They are of sturdy construction and afford the potatoes ample protection. This revolving circular table not only speeds up the filling of bags, but provides a package of potatoes of convenient size for the housewife to carry comfortably. The open mesh cotton bags afford easy inspection of contents. Watch this crew of speeders working with modern time-saving equipment. Rubber belts throughout are used. Early white rows, new potatoes dug in the morning, are on Pacific Fruit Express refrigerator cars before dark. Sackers keep pace with the sorters, for no equipment is better than its crew. No, it's not an exhibition, it's just routine, steady efficiency, paced by the equipment designed by engineers who really believe that time is money. Speed and safety are prime considerations in the Union Pacific service of linking producers with markets and getting the product there in good condition. Let's get aboard this potato special for a moment and see how the potatoes are scientifically loaded in the cars. Careful loading of bags is essential to prevent damage. Floor pads evenly spaced reduce bruising and permit air circulation. The 450-bag late crop load is started by stowing 5 bags upright against the bunker wall. The crosswise bags make a solid foundation, and the load builds rapidly with some sacks going into the stack lengthwise to interlock the load, thereby minimizing the possibility of bags shifting in transit. In building the 360-bag winter load, 5 bags are again placed upright against the bunker wall. The load builds up with the positions of the lengthwise bags reversed to prevent shifting. The airspace between bags and car walls reduces the possibility of freezing. Fall and spring styles for the 360-bag load call for more ventilation. Therefore, the bags are carefully spaced like this. Five upright bags again begin the formation of the 300-bag summer load. They are evenly spaced to form air channels throughout the load. The horizontal bags tie the load so that contact with sidewalls is avoided, reducing bruising of potatoes and chafing of sacks. The 300-bag summer load is quickly made into the 360-bag summer load by adding 1 bag on each side. In summer, ice prevents overheating of potatoes, and in the winter, heaters give protection from the cold. This system of loading, developed by the Union Pacific Railroad in cooperation with shippers to reduce loss from damage, is only one of the many ways this railroad works with agricultural interests along its lines. Whatever the crop, in whatever time of year, the Union Pacific gets it to the wholesale market with no loss of time. And the next stop in the journey takes us into the retail store, which has thus been speedily reached by rail. Over 1,000 carloads of potatoes are consumed in the United States every day. And now the destiny of the potato is fulfilled.